This is the first video kicking off our new unit on nonlinear functions. Mostly we're going to be working with polynomials. This is learning target 1, writing functions from roots. Our essential question today is how are roots used to write polynomial functions? So there's a bunch of new vocab we got to be familiar with as we continue into this new unit. The first new vocab is polynomial. Polynomial is the sum or difference of several terms with different powers. An example of this could be something such as 2x to the fourth power minus 3x to the third power plus x squared minus 6x plus 8. This is a polynomial. Many terms separated by additions and subtractions. All polynomials have degrees. This is the greatest exponent of a polynomial. So if I had a polynomial such as 5x cubed minus 3x plus 2, the largest exponent I see is the 3. Remember, there are other exponents such as the 1, but the largest exponent I see is the 3, so the degree of this polynomial is 3. We call that a degree of 3. There are lots of different ways to name polynomials. Here are several types of polynomials. Their names focus on the degree and the number of terms. Names for degree are things such as quadratic, which we're familiar with. Quadratics are polynomials with squares. Cubics would be polynomials with x to the third power. And quartics would be polynomials with x's to the fourth powers. We also have names for polynomials based upon how many terms there are. A monomial could be things such as a 2x, a x squared, or even a 6. All of these are examples of monomials. Binomials are when you take two terms and add or minus them together, such as x plus 6 or x squared minus x. Both of these are examples of binomials. Trinomials are what we're used to seeing with quadratics, such as x squared plus 5x plus 6, but they could include things such as x cubed plus x minus 1. Even though there's not a square in here, it is still a trinomial, 1, 2, 3 terms. So the one we're most familiar with is this one right here, which is a trinomial that is both quadratic and has 3 terms. So we call it a quadratic trinomial. This and right here, this would be a binomial. This is a quadratic binomial, and this is a cubic trinomial. So we can have multiple names for a polynomial, both for the degree and their terms. If we're given roots, meaning we're given the solutions to x, we should be able to recreate the function, understanding where these roots came from. Remember, these roots came from the factors. Remember that these signs are opposite. So it came from the factor of x plus 2. And this 5 came from the factor of x minus 5. If I want to create this into a function, I just need to make sure to put y equals. To write out what the polynomial really is, we're going to just do a little bit of multiplication. We're going to do x times x gives me x squared. X times 5 gives me negative 5x. 2 times x and 2 times negative 5 will give me a positive 2x and a negative 10. We do have like terms right here in the center. We have a negative 5x and a positive 2x. So my final answer to my function is y equals x squared minus 3x minus 10. We've done lots of this kind of work as we worked with quadratics, both in Algebra 2 and also in Algebra. What we're really going to get deeper into this year in Algebra 2 is dealing with 3 roots. With 3 roots, it means that it came from 3 factors. The first factor would be an x plus a 2, because it's opposite, x plus a 4, and x minus a 3. To multiply this out, we're going to need to do this in 2 stages. The first stage could be to multiply the first 2 pieces. So that's going to be x times x and x times negative 3. So that's x squared minus 3x. And then we're going to do 4 times x and 4 times negative 3, which gives me 4x and negative 12. Since I did not use the x plus 2, let's put it back where it belongs in front. Let's combine the like terms and get x squared plus x minus 12. Now it's time to multiply this x times all these other 3 pieces. X times x squared, x times x, and x times negative 12. This would give me a x to the 3rd power for x times x squared. So that's 1 power plus 2 more powers makes 3 powers. X times x is x squared, and x times negative 12 is negative 12x. Now it's time to do 2 times x squared, 2 times x, and 2 times negative 12. 2 times x squared is positive 2x squared. 2 times x is just 2x, and 2 times negative 12 is negative 24. I look now and I see I have several like terms. The first set of like terms I have is a x squared and a 2x squared. The other like terms I have is a negative 12x and a positive 2x. So my final answer will have the x cubed, an x squared and a 2x squared make a 3x squared. A negative 12 and a positive 2 make negative 10x, followed by the 24. We can even create functions for polynomials by looking at a graph. Remember that roots are the same thing as x-intercepts. So if we look at our graph and look to see where the graph crosses the x-axis, then we'll be able to find the roots. So one root is right here at negative 3. Another root is right here at negative 1. And my last root right here is at positive 5. This is not a root, okay, so we will not be using it. That right there is actually a y-intercept. So we don't use all intercepts, we just use x-intercepts. So let's start writing out a function that uses each of those. We have a negative 3 root, so my factor has a positive 3 root. We have a negative 1 root, so my factor has a positive 1. And we have a 5, so that's x minus 5. I'm going to start by multiplying those 2 pieces right there. As we get more familiar with multiplying, I'm going to start to write less steps. So when I multiply x plus 1 and x minus 5, I end up with x squared minus 4x minus 5. If you would like to, try to multiply those out to see the in-between steps. Now it's time to multiply these 2 pieces by all of these. X times x squared, x times 4x, and x times negative 5. Gives me a x cubed, a negative 4x squared, and a negative 5x. 3 times x squared, 3 times negative 4x, and 3 times negative 5x is going to give us a positive 3x squared, a negative 12x, and a negative 15. Combine the like terms. X cubed has no like terms. Negative 4x squared and 3x squared have like terms. That's going to end up being just a negative x squared, because negative 4 plus 3 is negative 1. Negative 5x and negative 12x will give me negative 17x, and the negative 15 has no like terms. This is the polynomial function that graphs this curve. So mostly what I want you to take away from this lesson is that we have lots of names for polynomials. The degree of the polynomial is the largest exponent. And to create a polynomial function from roots, we write out the factors with the opposite signs, and we start to multiply it, making sure we multiply every piece to every piece. Don't forget to rewrite after you do one set of multiplying before you continue with the next set of multiplying. Okay, if you have any questions, make sure that you shoot me a message on Remind, the text messaging service. Just shoot me a message using the number that I text you on. Otherwise, if you have other questions, you can write them down in your left column and you can bring them in the class.